Hello friends, welcome back to CIVIL3D Pro Tips and Tricks YouTube channel. Thanks for liking our videos. Please subscribe our channel for the regular update. And as we discussed in our last video that we are running the series of creating corridors for the intersections, various type like T intersection, four-leg intersection, very complex junction, and even the interchange. In last video, we have seen a T intersection and we have created that intersection in very traditional way by creating alignments and profile. Today, we're going to see the same things but in the different method. We're going to use offset alignment and connected alignment to create our junction, and we can see how easy that will be for the creating the T junction with the use of offset alignment and connected alignment. So as we discussed in the last video, and I'm going to explain again in case you are watching our videos first time, that to create any corridor, first thing what you need, the basic thing is to have alignment, profile, and cross sections. Without this, you cannot create any corridor in CIVIL3D. So you should have those three things. Once you have alignment, profile, and cross section, then you need to see how you model your junction. So you have to divide the junction into segment, and you need to finalize those. Third thing is important is the target. Well, the target is that whenever you see something is varying, I mean, traditional, the lane width is 3.65, but at some case you don't have a 3.65 lane. Like in this case, if I have to model this section, my lane width is keep varying on these sections. Like here it will be 1.2, then 1.5, then 2, its maximum, then again lower. So in this situation, you always has to use target where you have a varying width and the varying elevation, because the elevation on the existing would be different, elevation on proposed would be different. So in that case, you always have to use the target to model this bit of section. So, and then we have seen that what are the targets? Well, the targets, you have a three type of target: horizontal, vertical, and the surface. Horizontal target you can use like you can create a polyline and you can target that, and you can create the 3D polyline, feature line, alignment. And in vertical you have a 3D polyline which have some labels, feature lines again which have labels, and the profile. So that could you use to model this bit of area. So today we are going to see the use of connected alignment and offset alignment. Well, first thing we will build this bit of region because it will be easy. You have already alignment and the profile is already created. What you need to have, just the third requirement is the cross section, I mean the assembly. So as I told you earlier, always start your junction with the simple assemblies, then you can add the complex one, because once you create the assembly, simple assembly, you fix out all the labels and everything, then you need to model into detail. So we are going to create another, like I'm going in the section view or corridor and going with the create assembly where I'm going to give the name. Also, it's a good practice, always give it to some name. It will be road B and click OK, and I'll create here. So this is my assembly. Now I have to add some lanes like the sub assembly. So you need to go in home tab and you click here the tool palette, and where you can see the various assembly, you can click here and you can see the more assembly like basic, lane, shoulder, median, and you will get all kind of assembly over here. So we are going to create go into lane, and we are selecting lane super illusion, and we are going to create a basic lane assembly. You can modify this assembly. You can select this and open the property. You can modify as per your road width. So my road width is 3.5 and my camber or crossfall is 2.5. So we are done. Now I have alignment profile and cross section assembly. So I'm going to create the corridor. So I'm going here corridor and select create corridor. I give it to name road B and select my road B alignment and the road B proposed profile, and then select my road B assembly and click OK. Then I have to select the start and change how to run. I can run the assembly entire, but I need to create only from here. So I select my start station and my end station and click OK. It asks me rebuild corridor and your corridor for this region is created. I'll go and then I create surface for that corridor. So I'll create a top surface just to see the contour and select my style to contour and the top. Look, you always create the surface because in the surface you can see that it's the cross section is right, is the level is right, because the contour always tell you the real story of your design. So if you have any problem, it will be look showcase in the contour. So if the contour will look good, then your design is fine. And if you have any kink, so there will be some problem with the targeting or level. So you always create contour for your corridor to see that everything is right. So here the contour looks perfect. Now the next things else has to create the corridor with the offset assembly and curve return. For connected alignment first I need offset alignment. So I select my main alignment and here you get option of offset alignment. I click this and here you have to give the offset value for this. So I'll give my offset value is my lane width is 3.5 and then you need to create offset profile. So it will generate automatic profile for your offset alignment and it should be take minus 2.5% cross fall. So it will calculate level based on your profile, then it will calculate based on 2.5% what will be your level at the edge. So it create the profile accordingly automatically. Then I create OK and you can see that my offset profile created. Now if I have to connected profile, I need to have some alignment over here as well. Otherwise, I cannot create connected alignment. So what I'll do, I create alignment for my existing road. I'll give it to name existing road. Click OK. And with the tangent option, I just create some small portion of this road. Okay. Once I did it, what I'll do, I just add it my surface profile into it. So it will be act as a profile. So it will be act as an existing profile and I click OK. Okay. Now I have a connected alignment, offset alignment and profile. I have existing alignment and profile. Then I'll select my offset and here it is giving me a connected alignment option. So I click connected and now it is asking me to select another alignment. So I select existing. Now it is asking me location. So I click here and enter. And it is asking me radius value. So my radius is 15 and I need some overlapping area. So I'll give it to 5. Okay. And just click. And it is also like taking connected profile. So what it will do, it automatically create connect those two profile and create the profile in between. So it will take existing road slope and levels, it will take proposed road and slope level and it will create a profile in between, and it is taking, it will be showing which profile it is taking. So in case you have a multiple profile, you can always select which profile you want to take. So it is taking my offset existing ground and propose offset profile and I'll click OK. So you can see that alignment created, and if I go in detail, let me select the alignment and we'll see that the profile. Okay, and I go with the surface profile and I create draw in profile view, create profile view. So you could see that it automatically created profile and it is connecting at the end with the both existing and proposed profile. So it always be connected. The best part about it that it always get connected. So in case you change your profile level of this, it will automatically update accordingly. So you don't have to again go and connect with your existing and proposed profile. You don't have to change this. It will be automatically connect every time you change your centerline profile or your age profile or anything. So that's the benefit of it, connected alignment. Then you don't have to worry about connecting at both end. It will be automatically connected and automatically create the profile. Now the same thing we are going to do over here. We select the offset alignment. We select the connected alignment and existing alignment. Click OK. Select the side. So we'll select this side and click enter and give the radius 15 and some overlapping portion 5. You can see already taken the profile and just click OK. So by this it has created your alignment and profile, and what else we need? Just cross section. So you can see the alignment is going in this direction. That means we need to have a target on the left side to target this bit of area. I mean, to model this bit of area, our assembly will run on this and will target on existing alignment and profile and the proposed alignment profile to connect on the both in ends and to have a smooth road profile. So let's create another assembly. So go to assembly. This is road B, north side. Click OK, and let's take AOR on the left side. So I'll delete this right one. Now here this slope and the width will not be uh, useful because what it will use that target we are going to give. So it doesn't matter what we are giving our value here. The same thing, if we can see now it is running 0 here. I'm sorry, 0 here and here. In this case, you need the right side to target this alignment and this profile. So we create one more assembly. We'll just simply copy this. You can also copy this and delete this, and you can copy existing one as well. So I'll choose copy, or what you can do, another command I can show you. Let me control Z. I'll just copy it again. You can also use mirror command. So you can mirror this and click here and then delete this. So you can also use mirror command to choose the assembly on other side. Now it's done. You can also go here and change the side as well. So from here you can change left or right. So you can do plenty of options to create that. Now once I done it, I go again in my road B. Now I add baseline, which is my connected alignment, and another baseline which is connected alignments too, and the profile. Once I did it, and then if you can see here, if I'm clicking here, it will be highlighting which alignment it is. So based on that you can select okay which cross section you have to use. So wherever I click, it will be highlight what alignment it is. So here it will be a left side, and also you can click here and you can select your assembly in case you forget the name or anything. Done. And for the next one, add region. So I'm adding cross section to my baseline, and this three region has created. Then you have to choose your start and end station. So you can see it will be start from here and it will be end here. So I'm not running my cross section on overlapping area, I'm just running where the new area. Same thing here. And here. So you have to be careful the station that you select, correct the station, start station and end station. Otherwise, your corridor will run somewhere else and it will target something wrong thing. So you always have to be careful with your changes. Always check whether you have used the right station or not. So this is useful. Once I done the stainage, now I go to the target. This time I select alignment. First is existing, add, and then my road B. Okay, done. Now add my profile for both those alignment. They are the targets. So my existing profile and my road B proposed profile will be the target. Click OK. The same thing I need to do for another. You can also go here and you can select alignment in case you forget. So you can see that I'm selecting this alignment and this alignment as my target to create this region. And for this profile, again existing alignment, it's ground profile. And another one is proposed alignment and its profile. Click OK and OK and rebuild and it's done. Now here you can see, like I mentioned in my last video, that here you can need to see the frequency. I mean the frequency that cross section right now, the frequency, if you go and check and we click on the frequency, that it is applying the cross section at 20 meter interval and the curve location at 10 meter and the spiral 20, and that is the reason the corridors look like something like this. So what you need to do at the curve location or at the junction, you have to apply a low frequency, zero point 0.5, so it will be run smooth corridor for you. And I again apply this and click OK, and you can see now it's smoothly done. So you can see the connection and everything. And now I just delete the hatch. So in the contour you can see that whether it's properly connected or not. You can see the contours are properly connected from one region to another. As you can see here, you can see here there is small portion is still not connected. We can connect this. Now what you can need to do is to select your corridor, and here you get the plenty of option where you go and select edit frequency options, and then you select the region, click that, and you can add additional frequency where you see there is a gap. So I'm select this and select station, click OK and OK. So you can see now it is filling that part. Same thing again, select your corridor and then edit frequency, then select your region, and from here plus icon you can add additional frequencies and you can select this and hit enter and click OK and it will fulfill. So in this way you can detail model that section if anything left out. It's based on frequency. The more the frequency you will get, the smoother contour you will get. So if your frequency less, then you will may find there is a gap in the corridor connection or the contours are not that smooth. So whenever there is a curve location or something, you should give more frequency. It will look very smooth. And you can once you created this corridor and fix out everything level and everything, then you can add extra detail. Now if I want to add let's add some curves. Again, I use this curves and click OK. Click OK. In the curve return assembly, you have to use the curve on the other side. So you have to be careful where you're applying the curve. So you have to have careful here on the curve return assembly and here. So I'm not applying here. So you have to be careful where you're applying your curve return on the this curve portion. Okay, and then I will apply sidewalk. And then I choose cut and fill. So I go to the basic assembly and use this basic side slope cut and ditch. Okay, then once you add all those assembly, then you just simply rebuild this section. Now, when you apply the cut and fill assembly, then you need to apply the target. Like I mentioned already, there will be a surface target. So what you need to do, select your corridor and here's this edit target. You can directly go from here, click your region and you will see this is the surface target. I'll go over here and select my existing ground and click OK. Okay, so it is creating cut and fill for me. Daylight points, this and this. So you can edit the target from here as well. With using this option, you can edit the target as well. Okay, if this is done, and this is you can see from contour that everything looks fine. You can change style to triangulation, and now we can see in 3D. Just select this triangulation, go to the object viewer, and you can see perfectly model. Okay, and if you want to see the corridor, let's go and select my corridor and let's look that in the 3D. Go to object viewer and you can see my corridor. Okay, you can see the curves and gutter and everything. So in this way you can use your offset alignment and connected alignment and you can create corridor quickly than the previous traditional method. So yep, thank you. Thank you for watching our videos.